Hi, we are going to talk about finding all zeros of polynomial functions. So when we have a polynomial function and you have no zeros or factors given to you, this is typically what we do. We're going to make a list of possible rational zeros. We're going to use synthetic division and test them until you find one that works. If you're going to get something that's not quadratic, then you're going to have to repeat that process. If you get a quadratic, then you just solve the resulting quadratic equation by using a method that's going to work the best, and then you're going to list all the zeros that you found. Let's take a look at this problem. The leading coefficient is 1, so we're going to look at 30 and make all factors of 30 that are going to be our possible rational zero. That's plus minus 1, plus minus 2, plus minus 3, plus minus 5, plus minus 6, plus minus 10, plus minus 15, and plus minus 30. Okay, I have a bit of good news here. It's a lot of numbers to try, but we are not going to even try any positive numbers because positive numbers will not give you anything. So only negative numbers are going to be working because you have all pluses. So it has to be a negative number. So let's try negative 1. Negative 1. So we're going to have 1, 10, 31, 30. Okay. And let's see what happens with negative 1. So it's 1, negative 1, 9, negative 9. That's going to be 22, negative 22. We don't have 0, not 0. Okay. So 8, negative 1 does not work. Let's try negative 2. Negative 2, 1, 10, 31, 30. Bring down 1. That's going to give us negative 2. That's 8. That is negative 16. That is 15. That's negative 30. 0. Excellent. We got 0. So negative 2 is one of our zeros. We're going to mark that. And then this gives us a quadratic equation, which means we can solve our quadratic equation by an appropriate method. So we have x squared plus 8x plus 15 equals 0, and it just so happens that you can actually factor this one. It is x plus 3 times x plus 5 equals 0, which gives you x equals negative 3 and x equals negative 5. And we have all three zeros here because it's a cubic equation. We're looking for three zeros. So our solutions here are going to be negative 2, negative 3, and negative 5. You can put them in any order you want. Let's take a look at our next example. So we have this cubic equation, cubic function. We need to find all the zeros. We are going to list all factors of 21. The leading coefficient is 1. So we're just looking at 21. So plus minus 1, plus minus 3, plus minus 7, and plus minus 21. So not too many numbers. We're gonna have to try them. As you probably know, because you probably have done this before in the previous work, you don't really know which number is going to work, so you're gonna have to try one number, and I'm just gonna try 1. See if we get lucky. So 1, 3, negative 25, 21. So 1 comes down, 1, this is 4, 4, this is going to be negative 21, negative 21, 0 all. Good news. 1 is going to work. And also we started with the cubic equation. We got 1, 0, which means we have a quadratic equation, and we can solve it by any other appropriate method. So we're going to have x squared plus 4x minus 21 equals 0. This one can be factored. It factors as x plus 3 times, x minus 3 times x plus 7. Gives you 0, and then it's going to give us 3, and it's going to give us negative 7. So we have three numbers, and we're going to list them all, and that's exactly what we're looking for at most three numbers. 1, 3, and negative 7. Any order. Right. Let's continue on. this problem. So now we're getting into a bit of a more challenging task because this number is not 1. So we're gonna have to write 28 over 2. So we're gonna write 28 over 2. Remember, we do not simplify that. 28 comes from here, 2 comes from here. And we're gonna write all factors of 28 and of 2 and then divide each one by each one. So for 28 it's plus minus 1, plus minus 2, plus minus 4, plus minus 7, plus minus 14, and plus minus 28. For the bottom, good news, it's only plus minus 1 and plus minus 2. We still have to make all possible rational zeros, so we divide each by each. 1 over 1 is plus minus 1, 1 over 2 plus minus 1 half, 2 over 1 is plus minus 2, 2 over 2 is 1, we have that, 4 over 1 is 4, 4 over 2 is 2, we have that, 7 over 1 is 7, 7 over 2 is 7 halves, 14 over 1 is 14, 14 over 2 is 7, we have that, 28 over 1 is 28, 28 over 2 is 14, we have that. So these are our possible rational zeros. Where do we start? Well, I don't know, let's try 1 first. 2, negative 7, negative 8, 28. What's going to happen here? 2, 2, negative 5, negative 5, negative 13, negative 13, and it doesn't work. We get 15, no good. So if this happens, you're just going to have to continue trying other numbers. So that's exactly what we're going to do. But we're going to have to, we're going to try 2. So what happens here? So 2, negative 7, negative 8, 28, all over 2. That's going to give us 4. That's negative 3. That's going to give us negative 6. That's negative 14. Negative 28, and we have 0. Good. We have 0. So that's what we want. We already have 1, and this is a cubic equation. This was a cubic equation, now it's a quadratic equation, and we can solve it. So now we have 2x squared minus 3x minus 14 equals 0. This one can actually be factored. If you're getting stuck with problems like this, you can always use the quadratic formula. So what we're going to get here is going to be 2x minus 7 times x plus 2. Okay, so this one gives us x equals 7 halves. This one gives us negative 2. We have third degree polynomial function. We got 3 solutions. We are good. So 2, negative 2, and 7 halves. All right, moving on. This next problem is going to become quite a challenge, and you will see why very shortly. When you make a list of possible rational zeros, it's not too bad. It's 4 over 4. So it's going to be plus or minus 1, plus or minus 2, plus or minus 4 over plus or minus 1, plus or minus 2, plus or minus 4, which will give us plus minus 1, plus minus 1 half, plus minus 1/4, plus minus 2, 2 over 2 is 1, 2 over 4 is 1/2, we have those, 4 over 1, so plus minus 4, 4 over 2 is 2, 4 over 4 is 1, we have those numbers already. Here is what's going to happen here. If you take 1, 4, 1, well, actually we're only going to try negative numbers because everything is plus, so let's try negative 1. 4, 1, 16, 4. So we're going to get 4, negative 1, I'm sorry, negative 4. That's going to give us negative 3. That's going to give us 3. That's 19, negative 19. Well, we don't have 0, it's negative 15. Not good. Okay. Let's try to do, for example, negative 2. 4, 1, 16, 4. 4, negative 8, negative 7, it's 14, 30, negative 60, and negative 56, not 0. So you keep trying. The problem is the only number that's going to work here out of that list is going to be negative 1/4. 4 comes down. 4 times negative 1/4 is negative 1, which gives you 0, 0, 16. 16 times negative 1/4 is negative 4, and 0. This is the only number. You can try all the other numbers, and then you will see it. But this is good news. This is good, but you may get there through a pretty long process, because people usually try integer values first because they're easier to work with. But unfortunately, in this case, that's the only number that's going to work. You're just going to have to continue trying. I was lucky because I already knew what the answer was. So we have 4x squared plus 16 equals 0, right? And this is something I can divide everything by 4, so x squared plus 4 equals 0. We can solve this equation by using the square root property. X squared equals negative 4. X equals plus or minus square root of negative 4, which is going to give you plus or minus 2i. So the other two solutions that we're looking for are going to be imaginary. So we got negative 1/4 and then plus 2i and minus 2i. Okay. Moving on. Example 5. So now we're hitting a 4th degree polynomial, and this is where it gets challenging because you are not going to be able to find just one number. You're going to have to find two. But the good news here is you have 2 here, so your only possible rational zeros are plus minus 1 and plus minus 2. The number in front of x to the 4th is 1. So you don't have too many numbers to try. So let's try 1. So 1 is going to give 1, negative 1, negative 1, negative 1, negative 2. 1, 1, 0, 0, negative 1, negative 1, negative 2, negative 2. We get negative 4. No. Let's try negative 1. 1, negative 1, negative 1, negative 1, negative 2. 1, negative 1, so negative 2. Negative 1 times negative 2 is 2. Add these, that's 1. Times negative 1 is negative 1. That gives us negative 2. Multiplied by negative 1 is 2. And we have 0. Excellent. But we have a challenge because, yes, we found 1, 0. But this was 4th degree, so this is degree 3. We still need to continue trying. We need to find another number. I will save you the trouble. Another number that is going to work here is 2. Please remember, use the reduced polynomial. There's no reason to use the whole thing again, because we're trying to reduce it, remember? 1, 2, 0, 0, 1, 2, 0. So just as I promised. So we already have 2 solutions out of 4 that we're potentially looking for. We have negative 1, we have positive 2. So now this is a quadratic equation. We have x squared plus 1 equals 0. X squared equals negative 1. X equals plus or minus square root of negative 1, which is going to give you plus or minus I. We have a total of 4 solutions for a 4th degree equation. Negative 1, 2, I, negative I. Okay. Next problem. So we have another one, 4th degree. This one is going to be very difficult to do by yourself if you have a problem like that, because 36 has a lot of factors, and the number in front of x to the 4th is 4, which means you're going to have to list all factors of 36 and then divide by all factors of 4 and take every possible combination. So just for the sake of saving time, I'm actually going to tell you what zeros are going to work. But please remember, if you were given this problem, you would have to work through this whole process. I just don't want to make this into an excruciating search of zeros. I know 2 works. We have 4, negative 16, 25, negative 36, and 36. So 4 comes down. This is 8, negative 8, negative 16. That's going to give us 9. 2 times 9 is 18. That's going to give us negative 18. Times 2 is negative 36, and we have 0. Okay, but 4th degree, so this is degree 3. We can't use any formula here. We're going to have to do it one more time. We're going to have to look for a number. So now you can actually focus on this. You're going to have a reduced list of solutions, but I will tell you again what's going to work here. There's only one number that's going to work, and that number is 2 again, which means you're going to have a double 0. Remember to use the reduced polynomial coefficients. So we're going to get 4. That's going to give us 8, which gives us 0, which gives us 0 here. That's 9. That's positive 18, and that's going to give us 0. Excellent. So please remember 2 works twice, which means it's a double 0. It's a 0 with multiplicity of 2. And now we have this resulting equation. So it is going to be 4x squared plus 9 equals 0. So I can rewrite that as 4x equals negative 9. 4x squared equals negative 9. X squared equals negative 9 over 4. X equals plus or minus square root of negative 9 over 4, which is going to be plus or minus 3 over 2i. So we have 3 distinct solutions. We have 2 different numbers. We don't really need to list 2 twice. So what I'm going to write here is 2, 3 over 2i, and negative 3 over 2i. Okay. All right. I have one last problem, I promise. But, of course, the bad news is this is 5th degree, and this number is 60. It has a lot of factors. If you're going to start making a list of factors of 60, I'm going to write that just to show you. I will save us time, and I will tell you what numbers are going to work. But our list of possible rational zeros is plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, plus minus 6, plus minus 10, plus minus 12, plus minus 15, plus minus 20, plus minus 30, and plus minus 60. This is a complete list of possible rational zeros here. Again, I'll save you the trouble of searching through that. Again, if this was something that was given to you and you didn't have anything to go by, you will have to start trying numbers and try to find out what it's going to be. So one number that's going to work is going to be 2. 1, negative 1, negative 11, 19, 28, negative 60. 1, 2, 1, 2, negative 9, negative 18, 1, 2, 30, 30, 0. Here is a problem here. This is a 5th degree, so now we have 4th degree. We're going to have to keep trying. Luckily the number dropped a little bit, but that's not going to mean much because you're still going to have to try numbers. Another number that's going to work is going to be negative 2. 1, 1, negative 9, 1, 30. Remember to use the reduced polynomial. 1, negative 2, negative 1, 2, negative 7, 14, 15, negative 30, 0. Oops, excellent. Number 1, 0. But this is 3rd degree. So guess what? You need to look for one more. There's only one other number that's going to work. That number is going to be negative 3. 1, negative 1, negative 7, 15. Bring down 1, negative 3, negative 4. That's going to give you 12. That's 5. Negative 15, 0. Okay, you can finally breathe. You've got a quadratic equation, which you can solve now by using the quadratic formula or any other method that may work. So we have x squared minus 4x plus 5 equals 0. Factoring does not work here. You can solve it by using the quadratic formula. So x equals 4 plus or minus square root of 16 minus 4 times 5 over 2, which is going to be 4 plus or minus square root of negative, that's 16 minus 20, negative 4, divided by 2, which is going to be 4 plus or minus 2i divided by 2, and that's going to give us 2 plus or minus I. Alright, let's recap what we got so far. We have 2, we have negative 2, we have negative 3, and we have these two numbers here. So our complete list of all zeros of this function is going to be 2, negative 2, negative 3, 2 plus I, and 2 minus I. Again, these problems require a lot of perseverance because they are not always easy, especially once you go above degree 3, because anything above degree 3 requires you to find more numbers that are actually going to work before you can use the quadratic equation that you're going to get, and you're just gonna have to keep trying numbers. I know it's not an easy task and you don't always know which number to try first, but unfortunately there is no easy way to do that. But you know, with just enough effort and as long as you continue trying, you will eventually find those numbers. Okay, this is how it's done.